So in previous video I talked about this Young's double slit interference experiment, and I found the condition for maximum and minimum intensity points, and also we have found a relation for the position of maxima and minima that was given by this relation ym is equal to m lambda d by d. And then we also found a relation for fringe spacing that was given by lambda d by d. So in this video I'm going to talk about the intensity in double slit interference experiment. So you can see on the screen, so this is a double slit interference experiment, but you see this is a bright fringe and this is a dark fringe, but the intensity is not constant. So there is a continuous variation, that is that the edges are fuzzy. So there is a continuous variation. So this is what we are going to find. So we are going to find a relation for this intensity, that how does this intensity vary from the maximum to minimum. So obviously we have seen that edges are fuzzy, so there exists a variation of intensity. So this is what we are going to find. So this was the diagram in which we had slits S1 and S2, and two waves were originating, one were originating from S1, the other were originating from S2, and they were interfering at point P. So since we know that these two waves are coherent because they are originating from same single source S, therefore I can write for this first wave I can write the equation like this: E1 is equal to E naught sine of omega t. This is how we represent the light. And similarly, since these two waves are coherent, so this second wave can be written as E2 is equal to E naught sine of omega t plus phi, where this phi is the phase difference, and this should be constant in time because this is the condition for the interference. And here we have taken the amplitudes of two waves same, that is E naught 1 is equal to E naught 2, that is equal to E naught. So both waves have the same amplitude. These are our assumptions. So according to principle of superposition, that if this is a one particular point and one wave is passing through this point while the other wave is also passing through this point, so we can add these two waves to get the net amplitude or net wave, so to get the resultant wave. Okay, so if this E is the net wave at this particular point P, so we can add these two waves. So I can add E naught sine of omega t plus E naught sine of omega t plus phi. So I can take this E naught as common, so I am left with sine of omega t plus sine of omega t plus phi. But here I have this trigonometric relation, that is sine of A plus sine of B is equal to 2 times sine of A plus B by 2 cosine of A minus B by 2. So if I use this relation here, so this gives me this E naught as it is, and now this gives me 2 times sine of this plus this, so this gives me 2 omega t plus phi by 2 into cosine of omega t minus phi by 2. So this gets cancelled out, and here we have cos of minus phi by 2, and cos of minus theta is equal to cos of theta. So I can write this cos of phi by 2. So I can write this as it is, and then this. So this gives me 2 E naught and then cos of phi by 2 and then this. So that is equal to sine of, so I can separate this denominator. So this gives me omega t plus phi by 2. So omega t plus phi by 2. So this is 2 E naught cos of beta into sine of omega t plus beta. So here I am naming this phi by 2 as beta, just a simplification. So this is our equation. So I can name this entire quantity as E theta. Sorry, this is not E theta, this is simply E. So I can name this as E theta. So this is E theta and this is as it is. So now our equation look like this. So this is equal to E into E theta, which is the amplitude of the net wave, into sine of omega t plus beta. So this is our equation, but now we are interested in finding the intensity because this is our topics. So since we know that if we have a wave, something like here we have some wave exponential or anything, so if this is a wave, so this is the amplitude. So intensity is always proportional to this amplitude mod square. So I can, if I naught is the intensity due to one single wave, let's say this have I naught and this is I naught, so this will be proportional to E naught mod square, because I'm using from this relation that the corresponding intensity will be equal to E naught squared. And similarly, if I theta is the net intensity from this equation, so I can write this is equal to I theta is proportional to E theta mod square using this simple definition. So if I divide this equation by this equation, so I get I theta by I naught is equal to, the proportionality sign gets changed into equal, and then we have E theta mod square by E naught square. Since we know that E theta is equal to 2 E naught cos of beta, and this is a real, it is real value and cos is always real, so I can simply take its square. So this gives me 4 E naught square cos square of beta and divided by this E naught square. So this gets cancelled out and I am left with 4 cos square beta. If I multiply this I naught on other side, so I will get I theta is equal to 4 I naught cos square of beta. So this is basically an expression for the net intensity. So, and it depends on beta depends on 5 by 2. So basically this intensity depends upon the phase difference between these two waves. So this is our expression that we have found, that I theta is equal to cos square beta, where beta is equal to 5 by 2. So this is our expression, but now we want to find in this expression, or we want to express this expression in terms of some other parameter. So look here, if this is a complete wave, so this entire length is known as lambda, this is the length of a complete cycle, while this is from 0 to 2 pi. So obviously we can see from here that lambda is proportional to 2 pi. So lambda corresponds to, if there is a part difference of lambda, that will correspond to a 2 pi, because lambda is equal to 2 pi. And if I represent this part difference by d sine theta that we have already found in previous class, so this will be proportional to this phase difference, which is equal to phi. That is how we represented these two quantities. So this is what lambda is proportional to 2 pi and d sine theta is proportional to phi. So if I divide these two equations, so I get d sine theta by lambda is equal to phi by 2 pi. From here I can get the value of phi, that is 2 pi d sine theta by lambda, but because we are interested in finding the beta, that is equal to phi by 2, so I divide this whole expression by 2. So this gives me beta is equal to phi by 2, and if I divide this expression by 2, so this gives me pi d sine theta by lambda. So putting this value of beta into the above expression, so this gives me I theta is equal to 4 I naught cos squared, and I can put the value of beta, that is pi d sine theta by lambda. So now this is our expression for the intensity that is in terms of the path difference. So now let us, because we have already found the condition for maximum and minimum points. So now we check, can this expression gives us the maximum and minimum points, the condition of maximum and minimum points. So this is our expression. So we want to check that can we reach to this definition, to this equation. So for maximum intensity, you know that maximum intensity corresponds to the bright fringe. So this should be equal to, if for maximum intensity, so this is maximum value. So if I am going to get this 4 I naught, then this entire factor should be equal to 1. So maximum intensity will be equal to 4 I naught, and it is only 4 I naught if this factor cos square pi d sine theta by lambda is equal to 1. Or I can take under root, so this gives me cos of pi d sine theta by lambda is equal to plus minus 1. So cos, when cos is 1 or minus 1, so cos of 0 is 1 and cos of pi is 1 and cos of minus pi is minus 1. So we know this. So it's mean this is equal to m pi. So this is by the simple definition. So pi by lambda is equal to d sine theta is equal to m pi. So you can see here pi gets cancelled out and we have d sine theta is equal to m lambda, which is the same definition, which is the same equation which we have found in the previous class. So this is the condition for maximum point. So if this is the condition, then we can have this maximum intensity. Similarly for minimum intensity, this minimum intensity is of course 0, then we should have 0, and this will be 0 if this factor is 0, because 4 I naught is a constant, so this cannot be 0. So this factor should be 0. So we have cos square is equal to 0, and or we can say that taking square root, so we can say that cos of pi d sine theta by lambda is equal to 0. So cos is 0 at pi by 2 plus minus pi by 2 plus minus 3 pi by 2. So this gives me this angle pi d sine theta by lambda is equal to m plus half pi. This pi gets cancelled out and we get d sine theta is equal to m plus 1 divided by m plus half is multiplied by lambda, which is the condition for minimum intensity or for the dark fringe. So if the part difference is the half integral multiple of lambda, then we can have the minimum intensity, which is the same which we have found in the previous video. So you can also plot this intensity, you can see on the screen. So this is basically the how intensity is plotted, or I have plotted it here. So you can plot it against any parameter. So on vertical axis we have this I theta, which is the intensity, and of course from this our expression we know that maximum intensity is 4 I naught. So this line is basically representing maximum intensity, which is equal to 4 I naught. So we can plot this intensity here. So if this cos square beta is equal to 1, then we have maximum intensity, and this is 1 at 0, at 2 pi, minus 2 pi, and so on. And similarly for negative points we know that this is equal to minus pi, plus pi, and minus 3 pi plus 3 pi. So this will be minimum. So similarly we can plot it here, or you can plot it against d sine theta, you can plot it against lambda. So you have all the equations, so you know the relation from here, so you can plot this. So this is basically how the intensity varies. So at the center of the bright fringe it will have maximum intensity that is equal to 4 I naught, and then it decreases, and that at a particular point near the minimum, so it becomes 0. So there is a continuous variation of the intensity, and similarly for the other side, so we get this intensity distribution. So that was all for this video. In next video I will be solving some problems on this interference experiment from the exercise of HRK book. Thanks for watching.